everyone, myself is Divya Bahel, Assistant Professor in Chemical Engineering Department at LJ Institute of Engineering and Technology. The subject that we are going to continue is petrochemicals. So moving forward with this lecture, as far as this chapter was concerned, we studied about various properties and certain tests involved for different fractions of crude. Right, starting from refinery gases, we covered gasoline, naphtha, kerosene, diesel oil. So now we are going to study about fuel oil. What are your fuel oil? Those are classified as light gas oil and heavy gas oil. But these fuel oil are also called as lube oil. Okay. So what is the main purpose of this lube oil? Okay. They are used as a fuel for ships and power stations. Okay. These are the certain uses. But the main use of lube oil is as a lubricating oil. Right from name itself you can see that it is the prime use of this kind of fuel is as a lubrication. So moving forward, let's talk about lube oil. Now lube oil, it is the principal source of lubrication. Okay, engine oil, the oil which is put into the engine, right? What is that? The prime use is to apply as a lubrication for the piston, right? So it is a principal source of lubrication. Now this fraction is generally obtained when the boiling point is more than 350 degrees Celsius. Okay, so this fraction you can say it is heavy than other fractions, kerosene, diesel, etc. Okay, hence it is obtained as in the bottommost part of the crude distillation unit. Hence the temperature is of course very highest. Now they are generally obtained from vacuum distillation unit. So note down here, lube oil, the main product. Okay, see, in crude distillation unit you do get lube oil, but the prime source of lube oil production is vacuum distillation unit. So in vacuum distillation unit you will study further. The feedstock is what? The residue obtained from atmospheric distillation unit. Those are the feedstock which is supplied into the vacuum distillation unit, like residual bitumen, asphalt, okay, which is the residue product of atmospheric distillation unit. Those are used as a feed for the vacuum distillation unit. In vacuum distillation unit, further cracking take place. Okay, in presence of vacuum, your heavy compounds, they break down to give certain products, and lube oil is one of the prime product which is obtained in vacuum distillation unit. Now talking about the composition, they are mainly composed of paraffin, naphthens, aromatics and other unsaturates. Okay, the hydrocarbons may vary depending upon your process, right? And lube oil, see, they are classified on the basis of their application, on which area you have to use it. So based on that, the composition of lube oil may vary. Okay, the certain properties like viscosity and other parameters are different on the basis of their application. So now we will study about the various kinds of applications. Okay, various kinds of its classification on the basis of the application. But first note down that no single oil is suitable for all applications. As your application changes, okay, I can say that the engine oil which is used for petrol and diesel engine, that cannot be used for ships or plane, right? See, as application changes, your lube oil also changes. So no single oil is suitable for all the applications. Based on the application, your composition is different. So moving forward on the classification of lube oil. See, how your oil is classified, it is totally on the basis of application. So starting with machine and engine oil. Okay, this is the simple most classification. Now under these category also, your oil is divided on the basis of viscosity. So that is high viscosity lube oil, medium viscosity and low viscosity. Now application, high viscous lube oil is used for plain engines, right? Whereas medium viscous lube oils are used for petrol and diesel engines. Similarly, your low viscous is used for light machinery. One of the best example of light machinery is the sewing machine. Okay, that is a light machinery. So the oil which you are using as a lubricating oil, you cannot use that which engine oil of petrol and diesel engine, right? So you can see on the basis of viscosity, my application is changing. Second one is compounded oil. Now this oil, it is blended with vegetable oils. Okay, now why we need to blend it? It is to increase the wettability characteristics. Okay, now the application is steam engines. Okay, steam engines which is used for marine engines, right? Like for the ships, for boats. those kind of engine require compounded oil. Okay, where wettability is important parameter here. Now next is turbine oil. Turbine oil is used for steam turbines. Okay, in power plants, whatever the turbines are there, for that kind of oil you need turbine oil. Now here important parameter is that emulsion must not form. Emulsion is what? It is mixing of two immiscible liquids. Okay, so here emulsion must not form. It means oil and water must not form an emulsion. So for steam turbines, which is used in power plants, your lube oil has to have that property that emulsion should not form. Next kind of oil is cold test oil. Okay, so here important parameter is what? Pour point is important. Again, what is pour point? It is the minimum temperature at which your oil ceases to flow. Okay, so from name you can see that. Okay, your application is where? For Arctic climates. Okay, where your temperature goes beyond 0 degrees Celsius. Okay, it goes up to minus 13-14 degrees Celsius. So for that area, for certain machineries which are used in that Arctic climate area, you need to use cold test oil, where pour point has been reduced up to very large extent by adding certain additives. Okay, last one is corrosive oil. Okay, here your oil is blended with certain corrosive ingredients, okay, which improve the corrosivity. So what is the application? It is used for cutting and shaping metals. When the application is for when you have to cut the metals, right? For that kind of situation, corrosive ingredients are added. The next is certain tests and properties of lube oil. So what are the tests and properties which are related to lube oil? Those are viscosity, pour point, oxidation stability, flash point, carbon residue. Of course, viscosity is important. We saw as on the application. High viscous to low viscous, we saw the applications, right? So that test is also important based on the application. Pour point. If you have to use your crude, if you have to use your lube oil in the Arctic areas, okay, so pour point has to be taken into account. Third is the oxidation stability. We saw in the composition that unsaturates are present, right? So to unsaturates are present, hence they are prone to getting oxidized to form gum formation. Okay, hence oxidation stability is also an important property and test. Fourth is flash point. Of course, as far as safety purpose is concerned, your flash point has to be measured and tested. Last one is carbon residue. Now carbon residue is something important, new property you are seeing here. So let's see what is carbon residue. Let's see what is carbon residue. Okay, this is the property. The carbon residue is a property of cracking. Okay, well, of course your crude is subjected to cracking. As you increase the temperature, higher the temperature, the sensitive material may crack. Okay, so that property of cracking, it is shown by carbon residue. Of course, we discussed earlier also now itself that heavy oils, right, as you go into the bottom of the crude distillation unit, as you are increasing the temperature, less volatile components are present. Okay, so that those heavy oils at high temperature, some of the hydrocarbons in it might be sensitive to the temperature, and then thermal degradation take place. So what is thermal degradation? It is tendency to crack, right? So for such components you need to know the carbon residue. Now this leads to what? Carbon deposition. What is carbon deposition? That your high molecular weight hydrocarbons, like heavy oils, they crack into certain small units. Okay, in form of small hydrocarbons they are stored. They cannot be further vaporized. So that is your carbon deposition. So the amount of carbon formed at the end of operation shows the usability of oil at high temperature. So you can relate how carbon residue is important parameter over here. Okay, it shows the usability oil at up to what high temperature I can use my oil and further distill it to get as many as vapor fractions possible. If carbon residue is high, it means up to certain temperature only I can distill my crude to get vapors. More and more vapors cannot be formed as carbon residue is high. Low carbon residue means high amount of vapors I can form, high amount of components I can extract from the oil, leaving very less amount of residues. So the methods which are used to know carbon residue, okay, the certain test methods are Conradson method and Ramsbottom method. So what is Conradson method? You can see the apparatus is shown over here in a silica crucible. Okay, it's like a simple silica pot in which you take your sample. You heat your sample. Okay, you heat the silica crucible up to very high temperature, up to 500 degrees Celsius, you are subjecting it to heating. Now as heating take place, okay, more and more vapors of your crude are going to get out, okay. In the chimneys provided over here, see, as burning will form, okay, fumes are forming here. Aromatic contents are also high here, so fumes are formed. So what does chimney do? Chimney extract the fumes. Now this way you are heating your sample. Now you are heating it until last amount of residues are formed, okay. So afterward what you do, you cool this silica crucible and you weight it, okay. So yes, basis, suppose I took 10 gram of sample. So what are the steps this way the experiment is done? First is the preheating condition, right? You heat your silica crucible up to a certain temperature such that heating can take place, okay. That is your preheating. It is same like preparing your oven. So a suitable temperature has to be reached so that my fuel can burn, okay. It is approximately for 10 minutes, okay. Like up to 200 degrees Celsius, your initial heating period is done. Now is burning of fuel. First, what you are doing, you are preparing your apparatus, your silica crucible, so that your fuel can burn. Now burning of fuel will take place. Up to 13 minutes you will burn your fuel. Last stage is strong heating. Now in strong heating is the point where you heat when you take your temperature up to 500 degrees Celsius, right? So here at this temperature decomposition take place, okay. I am heating my fuel at highest temperature. So now is the point decomposition occurs. So it is for approximately 7 minutes. So at the end of the experiment, the amount of residue, it is weighed and it is expressed as % carbon residue present. So this was about Conradson method. The next method is Ramsbottom method, okay. You can see it is the Ramsbottom apparatus, and the adjacent to it, those are the small glass bulbs, okay, in which you take your sample and keep it into your apparatus. Now this is the insulated apparatus and the heating is electrically, okay. The electric coil, it heats the temperature. The temperature up to which this apparatus can work, it is up to 600 degrees Celsius. So you can see how high the temperature is. Here in your glass bulb, you take your sample of about 4 to 5 gram. Again you done the heating, okay. Your heating is done up to 20 minutes. The temperature, as I told you, it reaches up to 550 to 600 degrees Celsius. Now after cooling the sample, you weigh it down. So the amount of residue which is obtained after heating it, so that is your carbon residue. So how result can be known? See, the amount of carbon residue which is expressed as %, that shows you the quality of your crude. The good quality of crude is if your carbon residue lies between 0.2 to 1%. That is your good quality of your crude. It means more and more amount of your crude can be distilled to give you different fractions, right? So paraffinic crude gives you the least value of carbon residue. Hence we can say that paraffinic crude is the best quality of your crude, which gives you large amount of fractions. So that was for today's lecture. Thank you.